These are the Lesson 6.2 notes on polynomials and linear factors. Today we're going to talk about finding the zeros of a function and stating their multiplicities. We're going to find some polynomial functions in standard form with given zeros, and we'll also find relative minimums, maximums, and zeros on a graph. We're going to start with this first set of questions, which deal with finding the zeros of a function and stating their multiplicities. And there's probably some unfamiliar terms here, so let's kind of start at the beginning here. What does it mean when we talk about finding the zeros? The zeros is the idea of we're going to plug in 0 for y and we're going to solve for x. When you do that, when you plug in 0 for y and solve for x, what you're really finding are the X-Intercepts. So this is a fancy way of saying let's find the X-Intercepts of our graph. Multiplicities, you kind of see the word multiply in here, gets at the idea of how many times the same answer appears. So there's going to be some of these questions where we're going to get the same answer multiple times, and those are called the multiplicities. It's how many times the same answer appears. So in the first problem, to find these zeros, what we literally do is plug in 0 for y. So we're going to plug in 0 for y in this problem, and you'll notice that the problem says x plus 3 squared. When you square something, it means you're multiplying it by itself. So in this question, really what we're figuring out is what is x when we're taking x plus 3 times itself, when we're writing x plus 3 squared. Well, to solve this equation, we know that either this first factor has to equal 0 or the second one does, because when we multiply two numbers together and get 0 for an answer, it means at least one of these two factors has to be 0 as well. So if we look at this first thing, x plus 3, if we make this equal 0 and solve for x, we just subtract 3 from both sides, and you get x equals negative 3. If you take this thing and figure out what does x have to equal here to get 0, well, it's kind of like doing the same problem. If we make x plus 3 equals 0 and subtract 3 from both sides, we get x equals negative 3 again. We get negative 3 both times, so we say the answer is x equals negative 3 with a multiplicity of 2. And you can abbreviate multiplicity M-U-L-T. So there's one solution, it comes up twice, so there's like two multiples of the same answer. X equals negative 3, x equals negative 3. We say x equals negative 3 with a multiplicity of 2. For the second problem, finding the zeros, again, we're going to plug in 0 for y. And kind of like we did last time, if we ever have any powers, we're just going to kind of write them out. So x squared means x times 2x minus 1. And if we're multiplying these things together, either this equals 0, or 2x minus 1 equals 0. So it's pretty easy. In the first case, we could either have this first x equals 0, we could have the second x equals 0, or we could have this thing over here, this 2x minus 1 equals 0. So what we're going to do is we're going to solve this equation and figure out what x would equal to make this 0. So we're going to add 1 to both sides. You get 2x equals 1. Then divide both sides by 2. And you get x equals 1/2. So your answers are x equals 0 again, and x equals 1/2. So instead of writing it twice like we did here, what I'm going to do is I'm just going to say x equals 0, multiplicity of 2, comma, x equals 1/2. There's three answers altogether, but two of them are zeros, so we just say there's a multiplicity of 2. In our last problem, to find the zeros, we're going to plug in 0 for y. We have x times this x minus 5 3 times. X minus 5, x minus 5, x minus 5. And again, to get 0, we're going to try to make each of these things equal to 0. So if it's just an x, x equals 0 is one answer. If I solve this problem out, if I solved x minus 5 equals 0, and figure out what does x have to be equal to make this equal to 0. You add 5 to both sides and you'd get x equals 5. And you would do that for this other problem and this other problem. You would get 0 for this x, and then for these other x's, if we plugged in 5, we'd get 0. So there's three different answers of x equals 5. instead of writing out 5 3 times, I'm going to say my solutions are x equals 0 and x equals 5 with a multiplicity of 3, because there's going to be 3 answers of 5. 5 here, 5 there, and 5 there. All right. So what if we go the other way? What if we tell you the zeros and we said, all right, you've got to write the function. So we're going to go kind of the opposite direction of what we just did. If these are the answers, what does the original equation look like? We're going to start with y equals, because all the original equations start with y equals. And if we're talking about these are the zeros, if 2 is a 0, in parentheses, what we do is we kind of write the opposite of that number. So you might recall we just got x equals 5 as an answer, so we had x minus 5 in parentheses. If we have 2 as an answer, we're going to go x minus 2 in parentheses, x minus 4 in parentheses, x minus 6 in parentheses. And then your next step is we're going to crunch this out and see what we get. So this is a process of repeated multiplication. You probably remember the idea behind this. We're going to go first, x times x is x squared. Outside, x times negative 4 is negative 4x. Inside, negative 2 times x is negative 2x. And negative 2 times negative 4 is positive 8. We're still going to multiply this by x minus 6 when we're done. And if you want to simplify things for just a moment, you can add the like terms in the middle. Negative 4x minus 2x is negative 6x. This is going to take us about 2 more steps. The next step is going to be multiplying everything in the left-hand parentheses by everything in the right-hand parentheses. There's going to be 6 multiplications altogether. I'm going to start by multiplying x squared times each of these things. X squared times x is x cubed. X squared times negative 6 is negative 6x squared. Then I'm going to take negative 6x times each of these things. So negative 6x times x is negative 6x squared again. Negative 6x times 6, negative 6 is positive 36x. And then we're going to multiply the 8 times both of these things. We're going to get 8x minus 48. And if you simplify this answer down, there is an x cubed. When you crunch out the x squareds, you get negative 12x squared. When you add the x's, you get 44x. And you have a minus 48 at the end. That's what the original function looks like. Now that one took a little bit longer to do. Some of the problems are going to be a little bit easier. Case in point, if these are your zeros, x equals 0, 2, and negative 2, check this out. You're always going to start with y equals, and you might remember when we had 0 earlier, like in the problem right above here, that just meant that you had an x. We also had that in the third problem. So if x equals 0 is one of your answers, you're just going to have a plain old x in the problem. If you have a negative, like x equaled negative 3, we had x plus 3. Here I have negative 2, so I'm going to write x plus 2. And for this 2, we're going to go x minus 2, just like we did in the previous problem, where we had a 2 and we wrote x minus 2. Now I could multiply the x times the x plus 2, but what I'm going to do here is something a little different. When you're multiplying, you're allowed to multiply anything together. And I'm going to start by actually doing the FOIL, or the multiplying of x plus 2 times x minus 2. I'm going to leave this x alone. I'm going to multiply this stuff together. Because when you do that, check out what happens. You'll have x times x is x squared. X times negative 2 is negative 2x. But on the inside, 2 times x is 2x. And positive 2 times negative 2 is negative 4. By doing this, what you're going to find out is that the x's in the middle will cancel each other out. Negative 2x and 2x is 0. They cancel. So all you have is x squared minus 4. And this is going to make your multiplication work out a little bit nicer in the end. We've got one more step to do here. We need to distribute the x times the x squared into the negative 4. So if you do x times x squared, you get x cubed. And if you do x times negative 4, you get negative 4x. In class, you'll have an opportunity to crunch out this problem as well. If you're wondering what the solution is, the answer to this problem is going to be y equals x cubed minus 7x squared plus 8x plus 16. And you'll have an opportunity to work on this during class today. Let's take a look at this next set of problems. One thing you're going to be asked to do today is find values called relative minimums, maximums, and zeros on a graph. And I've kind of listed some instructions for finding relative minimums on a graph. A relative minimum is basically a low point on the graph. So any point that you would consider to be a low point. You'll notice we have one here. We have one here. We have an absolute minimum here. That's the absolute lowest point the graph gets. Those are considered relative minimum points. If it's the lowest point, you can call it an absolute minimum, but it's still a relative minimum also. Any point that's a maximum value, we've got a maximum value here and here. These are like high points on a graph. Those are considered relative maximums. So there's two questions that we're going to try to look for relative maximums and minimums to. And the first one is this equation right here. So I'm going to go to my calculator. I'm going to go to y equals on my calculator, and we're going to type in this equation. Y equals x cubed minus 14x squared plus 48x minus 52. We're going to use a standard viewing window that goes from -10 to 10 on the x-axis and -10 to 10 on the y-axis. Once you enter the equation under y equals, we're going to go to second trace. And the first thing we're going to find are relative maximum values. So I'm going to go down to calculate number 4, maximum. Once your function is graphed, there's going to be a question that says left bound. For left bound, we're going to use your cursor, and we're going to trace to the highest point and then go a little bit to the left of it. That's the left bound. You hit enter. For right bound, we go back to the highest point using your left and right arrows. Go a little bit further to the right of the highest point and press enter again. When it says guess, you move to the middle of the graph, press enter, and the value you get, mine says 2.26, is what you're going to write for your relative maximum here. Round this number to the nearest hundredths place. Now for relative minimum, you're going to notice that this graph doesn't seem to show kind of what's going on down here in the bottom. If you need to adjust your window at this point, that's fine. I'm going to adjust my window to -100 so I can see a little bit further down my graph for the y-min. And when I do this, I can now see that my graph has a relative minimum point right here that I'd like to find. So we're going to go to second trace. I'm going to choose the minimum option. I'm going to go left bound a little bit to the left of the lowest point. So I move my cursor to the lowest point of the graph and just go a little bit to the left of it. Press enter. It's going to say right bound. I'm going to move my cursor a little bit to the right of the lowest point. Hit enter again. And then for guess, I'm going to move my cursor right to where the lowest point is. Hit enter a third time. And it gives me an x coordinate of x equals 7.07. I'm going to write that for my relative minimum. You do not have to write the y coordinate. Zeros are any place the graph crosses the x-axis. It almost looks like the graph crosses the x-axis between 2 and 3. But if you look at the graph carefully, there's only one actual zero in the graph. Doesn't quite hit it here, but it does right there. So we need to find that point. So if you go to second, trace again, select the 0 option. For left bound, move your cursor to the right until you get to right about where the graph crosses the x-axis. And then once you get to that value, we're going to go a little bit to the left of that value. So here comes my cursor. It comes off the screen kind of quickly. So there's about where it crosses. I'm going to move a little bit to the left of it. Hit enter. For right bound, I'm going to move to where I think it is. Go a little bit to the right of that. It's actually off my screen. We're going to hit enter again. And then for guess, I'm going to move my cursor as close as I can to this intersection point. Hit enter. And it tells me that 9.5, we'll call it 4 approximately, is the 0. I'm going to sketch a graph of this as best as I can over here. And that's kind of how you handle this. There's one more problem we're going to have you try out in class. The answers will be posted in class for that one.